Hello guys, hope you have been having a very lovely day. In this session, we'll be learning how to find out the eigenvalues and the eigenvectors when we're given a matrix. So first, let us start with a 2 by 2 matrix. So let me tell you once, because eigenvalues or eigenvectors, if you want to find out eigenvectors, you will have to find out eigenvalues, but eigenvalues are nothing but the roots of the characteristic equation of a matrix. So because I told I'll be starting with a 2 by 2 matrix, so let me take 5, 4, 1, 2. This is my matrix. So the characteristic matrix of this matrix A is A minus lambda I. So I, as you all know, is 1, 0, 0, 1, is an identity matrix. When in 2 by 2, it is 1, 0, 0, 1. So now A minus lambda I is equal to 5 minus lambda, 4, 1, and 2 minus lambda. This is the one written in peach, is the characteristic matrix. So the given matrix is A, and the characteristic matrix of A is A minus lambda I, which is 5 minus lambda, 4, 1, and 2 minus lambda. So what I'm talking about is the characteristic equation of the matrix. So once I have the characteristic matrix, finding out the characteristic equation is nothing but finding out the determinant of the characteristic matrix. So I have 5 minus lambda, 4, 1, 2 minus lambda. So finding out the determinant and equating it to 0 is the characteristic equation of the matrix. So 5 minus lambda, what is the determinant? It is 5 minus lambda into 2 minus lambda into 2 minus lambda minus 4 into 1, because 1 I'm not writing it anyway because 4 into 1 is 4. So this is equated to 0. So the determinant of this matrix is this. This is the determinant of this matrix that we have to equate to 0. That is how we are going to find out the roots of the characteristic equation. So these roots will be your eigenvalues. So solve it. On solving, what are you going to get? You're going to get lambda square minus 7 lambda plus 6 is equal to 0. So writing it further, you can write it as lambda square minus 6 lambda plus 6, right? So lambda minus 1 into lambda minus 6 is equal to 0. So now, what are the roots of that characteristic equation? They are 1 and 6. So the roots are lambda is equal to 1 and lambda is equal to 6. So the roots of the characteristic equation of the given matrix are 1 and 6. So there we are. These are the eigenvalues. This is how you find out the eigenvalues of a given matrix. So the next concept is eigenvectors. Now let us find out how to find out the eigenvectors of a matrix. Note that we already know what the eigenvalues of the matrix are. So the eigenvalues of the matrix which we have solved before are 1 and 6. So 1 and 6 are the eigenvalues of the previous matrix. So now how do we find out the eigenvectors? So this question is answered by simply writing Ax is equal to 0. So this equation answers everything. So what are eigenvectors? Eigenvectors are those when which the matrix you multiply it with the parent matrix, you're going to get a 0. So you might tell me when x is equal to 0, the product will always be a 0. So why can x be a 0 vector, that is a vector consisting of all zeros? The answer is no. A matrix or null matrix, a 0, 0, 0, or when you're finding out a 2 by 2 matrix here, so 0, 0, a column 0, 0 matrix cannot be an eigenvector. Especially in your exam, if you're gonna write it like this, you're not gonna get marks. So never write x is equal to 0 as an eigenvector. Always find out the eigenvector based on the values of you have found out for your eigenvalues. So now to find out eigenvectors, the first step you're gonna do is ax is equal to 0. So what is a? What is a here? A is the a minus lambda which we have written before. That is 5 minus lambda, 4, 1 and 2 minus lambda. This is the characteristic matrix. We are talking about the characteristic matrix multiplied by x, which is going to give you a 0. So now we have this characteristic matrix. We need to find out x. That is, we need to find out two elements, x1 and x2. Let me just make it clear for you. We need to find out the two elements, x1 and x2, which, when multiplied with the characteristic matrix, gives you a 0. Remember, do not write x1 into x2 is equal to 0. So the first step I'm going to do is, the first value is lambda is equal to 1. I have lambda is equal to 1 and lambda is equal to 6. I'm going to start with lambda is equal to 1. So when lambda is equal to 1, 5 minus lambda, that is 5 minus 1 is 4. This 4 comes down as it is, 1, and 2 minus 1 is 1. So this matrix, when multiplied with x1, x2, gives you 0, 0. Clear? So this is how you're going to write the equation to find out the eigenvector. So your eigenvector is nothing but your x1, x2. So now solve this, and solve this, and there you are. See, write down the equations. You're gonna get 4 into x1 plus 4 into x2. 4x1 plus 4x2 is equal to 0, and x1 plus x2. x1 plus x2 is equal to 0. So now, looking at those two equations, do you see any difference between them? Like in the first equation, if you're taking out 4 common, still you're left with x1 plus x2 is equal to 0. So all you know is you have just one equation, which is x1 plus x2 is equal to 0, which in turn means x1 is equal to minus x2. See? So in these cases, if you are able to solve these equations, it's excellent. But in cases when you're unable to solve those equations, you will have to make a substitution like x1 is equal to minus x2, and you can take this x1 is equal to alpha, right? So what do you get? What is the eigenvector you get? You can take x1 is equal to alpha. I have taken x1 is equal to alpha. So my eigenvector is x1, x2, right? But x1 is alpha and x2 is minus x1, because x1 is minus x2, x2 is minus x1. So x2 is minus alpha. So what do you make of this? What do you make of this? You can take out alpha common out of this. So this is equal to alpha into 1 and minus 1. Right? So there we are. This gives the answer, and 1 minus 1. This column matrix is your eigenvector. So 1 minus 1 is the eigenvector of the parent matrix A, corresponding to lambda is equal to 1. Don't be confused. For every eigenvalue you get, you will get an eigenvector. So here you have alpha minus alpha. You have taken out alpha common, so you're left with 1 and minus 1. So 1 and minus 1 is the eigenvector for this matrix A, corresponding to the eigenvalue lambda is equal to 1. So now we need to find out the eigenvector for the corresponding eigenvalue. Lambda is equal to 6. So what is the characteristic matrix? It is 5 minus lambda, 4, 1 and 2 minus lambda. So this is my matrix. This is my characteristic matrix. So I'm gonna substitute lambda is equal to 6 in this. What am I gonna get? I'm gonna get minus 1, 4, 1 and minus 4. Right? Am I right? Right. So let me just remove these things. So I have my matrix. Minus 1, 4, 1 and minus 4. This, when multiplied with x1, x2 gives you 0. So we need to find out. So x1, x2 giving you a 0. Okay, I'll write it here again. Minus 1, 4, 1 minus 4. When multiplied with x1 and x2 gives you 0, 0. So what are you waiting for? Write down the equations. What are the equations? Minus x1 plus 4x2 is equal to 0. And x1 minus 4x2 is equal to 0. So looking at the above equations, what are you getting? Are you able to solve those two equations? If I'm gonna add them, it's gonna be 0. If I'm gonna subtract each other, it's gonna be 0 again. It's not gonna be any use because it's not helping. So the only equation I'm gonna use is this. So what is it? x1 is equal to 4x2. If I'm able to establish a relation between two variables, that is enough to find out the eigenvector. If you're able to solve those equations, it is really good, but in cases when you're unable to do that, you have to do like this. You have to establish a relationship between two variables. So once I have x1 is equal to 4x2, I need to, what shall I take? I'm gonna take alpha is equal to x1. So let me take x1 is equal to alpha. So what is my eigenvector? This is my eigenvector. So x1, x2 is my eigenvector, which is equal to, I'm just making some space, which is equal to, x1 is equal to alpha and x2 is equal to 4 alpha. Am I right? Yes. So wait just a minute. 1 by 4 alpha. So x2 is equal to 1 by 4 alpha. So you can write it as, now you can take out alpha, and that is going to be 1 and 1 by 4. This you can also modify as, you can make 4 above. You can write, say you're multiplying it with 4. Because this is a constant, it doesn't matter. So I can write 4 alpha here and write 4 here and remove the 1 here. And making this 1, 4 and 1. And you can also write, you can now remove 4 here and write 1 and 1 by 4. Either way is correct. So but still preferred is that you use whole numbers in the eigenvector, because you'll be solving a few problems where you're required to have whole numbers in your eigenvectors, because that is gonna make your work easy. So 1, 4 and 1, right? So this 4 is just a constant. So my eigenvector is 4, 1, the column matrix. So this is how you find out the eigenvalues. I hope you're clear with this, right? It is simple because if you had taken x2, you find out the eigenvalues and eigenvectors for a given matrix A. Thank you. Hope you understood this concept and have a lovely day. And if you have an exam tomorrow, all the very, very best. Thank you.